Welcome to today's Explainer. We're jumping right into the deep end today to talk about drones or unmanned aerial systems. These things are an absolute multidisciplinary engineering marvel, going way, way beyond the whole flying camera stereotype. We're going to completely unpack their anatomy, their history, and where this wild tech is heading next. To really set the stage, listen to this quote straight from our source material. Drones represent the convergence of multiple technological revolutions: aviation, computing, artificial intelligence, and automation. I mean, that is a massive statement, right? We aren't just talking about some remote-controlled toy you buy at the mall. We are literally talking about the intersection of the most significant technological leaps of the 21st century, all packed into a single flying frame. It really puts the sheer scale of this tech into perspective. Now, just to make sure we're all speaking the exact same language here, you'll constantly hear experts use the acronyms UAV, Unmanned Aerial Vehicle, or UAS, Unmanned Aircraft System. Basically, it just means an aircraft operating without a human pilot physically sitting inside it. It could be controlled remotely by an operator on the ground, or increasingly, it's flying completely autonomously using its own onboard computers. Here is our incredibly packed roadmap for today. We'll start with origins to modern marvels, then open the hood for anatomy and flight mechanics. After that, we'll dive into smart tech and AI, explore how they're changing the world, and finally wrap up with challenges and future horizons.
Okay, let's kick things off with Section 1, Origins to Modern Marvels.
The historical journey here is actually pretty fascinating. The early concepts date all the way back to the 19th century with balloon warfare experiments. Fast forward to World War I, and you start seeing the very first radio-controlled flying machines. The military obviously drove massive developments throughout the 20th century, but the real foundational breakthrough came later with the invention of GPS and microprocessors. But here's the real game changer, the 2000s. The massive consumer boom in smartphones meant that things like sensors, batteries, and processors suddenly became incredibly small, incredibly cheap, and incredibly powerful. Honestly, it was that smartphone tech explosion that practically overnight catalyzed the modern civilian drone revolution. So now that we know how we got here, let's actually take one apart. Section 2, Anatomy and Flight Mechanics. To really wrap your head around this complex hardware, it helps to think of it like the human body. The flight controller, that's the brain, constantly handling stabilization and navigation. The propulsion system, so the motors and propellers, those are the muscles providing the actual thrust. Your power system and electronic speed controllers, or ESCs, act kind of like the nervous system, rapidly distributing energy and relaying exact speed commands. And finally, the sensors act as the eyes and ears, gathering crucial data about the environment. For this thing to fly, the whole shebang has to work in absolutely perfect harmony. So how do those muscles actually get this machine off the ground? Well, it's a constant, invisible battle of four fundamental aerodynamic forces. First up, you have lift. That's the upward force generated by the propellers pushing air down. Opposing that is weight, literally just gravity trying to drag the drone back down to Earth. Then you've got thrust, which is the forward or upward drive from the motors. And thrust is constantly fighting against drag, which is just the natural resistance of the air itself. At the end of the day, successful, stable flight only happens when lift and thrust continuously overpower weight and drag. Now, the physical shape of the drone completely changes how it handles those aerodynamic forces, which in turn dictates what it's actually used for in the real world. Take multi-rotor drones, like your standard quadcopter. These are everywhere because they're super easy to control, they can take off straight up, and they hover perfectly in place, which is ideal for intricate close-up inspections. Contrast that with fixed-wing drones. These glide much more like traditional airplanes. Because of that aerodynamic efficiency, they offer immense flight times and far greater range, making them the go-to for something like large-scale agricultural mapping. But regardless of the frame's shape, you've got to have the right muscle powering it. A lot of early models or cheap toy drones use brushed motors because, well, they're cheap, but they are highly inefficient. If you look at modern professional UAS platforms today, they overwhelmingly rely on brushless motors. They are significantly more powerful, they have a vastly longer lifespan, and they've absolutely become the gold standard for reliable flight. All right, let's shift gears from the physical muscles and talk about the brains of the operation. Section 3, Smart Tech and AI. The sensor payloads on a modern drone are frankly staggering. They allow these machines to perceive the physical world in ways that we humans simply can't. Sure, they've got standard optical cameras for crisp high-def video, but beyond that, you've got thermal cameras detecting heat signatures, literally life-saving for finding a lost hiker at night or spotting a hidden hotspot in a forest fire. Then there's LiDAR, which fires rapid laser pulses to build millimeter-perfect 3D maps of the terrain. And my personal favorite, multispectral sensors, which capture light completely beyond human vision to analyze the invisible health metrics of crops. It's almost like giving the drone superpowers. But here's the thing. All that raw sensor data means nothing without a brain to process it. That's where artificial intelligence steps in and completely changes the game. AI transforms these things from basic remote control tools into intelligent, decision-making entities. We're talking real-time object detection, where the drone instantly recognizes a car versus a person. We're talking autonomous navigation, letting it fly its own complex missions safely. We are even seeing swarm intelligence, where dozens of drones communicate and cooperate as one massive, unified hive. AI is even handling predictive maintenance now, crunching the drone's own internal data to warn you about a motor failure before it ever actually happens. Armed with that perfect blend of physical hardware and cutting-edge AI, it's really no surprise these systems are deeply embedding themselves into our daily lives. Section 4, Changing the World. Commercial drones are completely ubiquitous across the global economy right now. Basically, every major sector is using them to solve incredibly tough real-world problems. In agriculture, they're optimizing irrigation and drastically reducing pesticide use. Construction crews use them to map complex 3D sites in a matter of minutes. The energy sector relies on them to safely inspect towering wind turbines and live high-voltage power lines without putting humans at risk. Logistics companies are racing to use them for faster, cheaper cargo deliveries to remote areas. And obviously, in media and entertainment, they have totally revolutionized how we broadcast sports and shoot big cinematic films. And looking beyond just the commercial side, drones play incredibly high-stakes operational roles globally. And there is a really fascinating duality to look at here. On one hand, as our source details, modern militaries utilize highly advanced UAVs for critical reconnaissance, electronic warfare to disrupt enemy comms, and precision strike operations. But on the exact flip side of that coin, the scientific community is relying on those exact same base technologies to literally save the planet. Researchers are deploying specialized drones to monitor melting glaciers, map out super delicate coral reefs without ever touching the water, and track endangered wildlife across vast, completely inhospitable terrains. As incredible as all of this tech is, we definitely aren't at the finish line yet. Let's move into our final section, challenges and future horizons. It's absolutely crucial that we acknowledge the serious limitations holding this technology back today. For all their technical magic, current consumer drones are heavily bottlenecked by battery capacity. Most of them are tapping out after just 20 to 50 minutes of flight time. They're also highly sensitive to severe weather. High winds or heavy rain will ground them real quick. Beyond the physical stuff, you have severe security risks. Radio frequencies and GPS signals can be hacked or spoofed by malicious actors. And naturally, having thousands of cameras constantly buzzing around in the sky raises massive, incredibly complex legal and ethical questions around data protection, airspace management, and our basic personal privacy. However, engineers don't look at these limitations as dead ends. They see them as the exact friction points right before the next great leap. In the near future, we're talking about hydrogen-powered drones that can stay airborne for hours instead of minutes. We're looking at the very real rise of urban air mobility. And yes, I mean literal drone taxis transporting human passengers across major cities. Moving into the deeper future, we'll likely see swarms of completely autonomous drones fully integrated into AI-powered smart cities. They'll be seamlessly handling traffic monitoring, emergency rapid response, and vital infrastructure management, all without a human ever even touching a joystick. Which brings us to our final thought for today. The engineering puzzle, that's rapidly being solved, but the societal puzzle is really just beginning. As thousands of AI-powered swarm drones inevitably integrate into our smart cities, seamlessly managing our daily infrastructure and dropping packages on our doorsteps, how are we going to balance that ultimate sci-fi level of convenience with our fundamental right to privacy? It's a wildly fascinating frontier, and it's one we are all going to have to navigate together. Thank you so much for joining me on this explainer. Keep asking those great questions, and I'll catch you next time.